Hi there, it's time for our next lesson, which is on graphing from slope intercept form. Just a quick reminder before I dig into that lesson for today of the things that we've already covered in slope so far. Keep reviewing them because they get tangled in your mind really easily. So the first thing that we talked about was how to graph slope from a line. What we're going to do when we're graphing slope from a line, we're going to take a look at that line that we have, and we're going to look for two places where that line crosses the intersection. So here would be a point right here, because if I look at the graph paper, I'm looking at the vertical and the horizontal lines, and where those cross, they form an intersection. So if the line touches that intersection where those cross, that is one of the points we're looking for. So I'm going to follow that along. I found another point here. So those are my 2 points that I find. I'm going to start at the left dot, and I'm going to do the vertical change first. So imagine an elevator going up, if you will. So it's my vertical change. It's my change in y. It's the first thing that I count. And that would be 1, 2, 3, 4, 5. So there was a vertical change of 5. It went up 5, so it's positive 5. If that had gone down, it would have been negative 5. Then I do my horizontal change. I run along that side. So my run, or my horizontal change, would be 1, 2, 3, 4, 5, 6, 7. And then I write that as rise over run. So my slope, using the lowercase m, would be 5/7. So I always write slope using that lowercase m to indicate slope, and I always write it as a whole number or as a fraction. I never write slope as a decimal. So don't take 5 and divide it by 7 and get a decimal for that. It's always a fraction or a whole number. The next thing that we talked about, erase that. Next thing we talked about was graphing from 2 points. Graphing from 2 points. So if I have 2 points, let's say that I take 4 and 8 and -2 and -5. So I'll just pick 2 points. But I'm going to solve from graphing from 2 points. The formula was y2 minus y1 divided by x2 minus x1 was the formula that we were going to do. So we're going to take y2 and subtract the first y and the second x and subtract the first x. So it kind of makes a double rainbow. So it's y minus y, x minus x. Make sure you keep the y's lined up with the y's and the x's lined up with the x's. So this then would become, let me erase this, make a little bit more screen space for us today. So that then would become -5 minus 8, and it would be -2 minus 4. Now, one of the things that I find easier in solving these is to take that subtraction and change it to addition. So I'm going to add the opposite. The first number stays the same. I don't make any changes to the first number, leave it exactly the way that it is, but the subtraction becomes addition, and the number that was after it changes from positive to negative or negative to positive. This then becomes add the opposite. So we'd end up with -5 plus -8 is -13. And -2 plus -4 is -6. And of course, a negative over negative is a positive. So my slope would be 13/6. Again, leave it as a fraction or a whole number if it simplifies to that. Simplify if you can, but never a decimal. But do make sure you simplify if you can. Now, for solving those, and we happen to get a 0 somewhere along the way, because that's going to come up sometimes, if my slope ends up being, let's say, 0/6. If I have 0/6, if I have 0 things, can I put them into 6 groups? Is that possible? Can I pass out 0 to everybody? Can everybody get nothing? Yes, everybody can get nothing. So when I graph that, my slope is going to be a horizontal line crossing the y-axis at some point in time. If it's the other way around, if my slope has a 0 in the denominator, if I have 6 things, can I put them into 0 groups? I can't. They have to go somewhere. So that slope is undefined. It's not possible to divide by 0. So that's undefined, and it will be parallel to the y-axis crossing the x-axis at some point in time. The last thing that we talked about, a quick review, is graphing from standard form. So if I'm graphing from standard form, that's the ax plus by equals c is the formula that tells us that it is standard form. And if I plug numbers in there, let's say I have 4x plus 2y equals 8. Let's say that's how the numbers go. Then because what I'm looking for is the intercepts, I'm looking for where on the y-axis does that line cross and where on the x-axis does that line cross. Because if I can find those 2 points, let's say that I know the x-intercept is here and I know the y-intercept is here, if that's what it turns out to be, then all I have to do is connect those two dots and I can graph my line. So being able to find the x-intercepts and the y-intercepts is very important. Now we're able to plug 0 in for x and 0 in for y because that's how y-intercepts work. If I'm on the y-intercept, x is 0, and then y has some value. If I'm on the x-axis, y is equal to 0, and x has some value. So that's why we can plug those zeros in there. So I can plug a 0 in right here and get 4 times 0, which is going to make that go away. So if I'm solving for y, I cover the x. So imagine that I cover the x. If this goes away, I'm left with 2y equals 8. And I use my one-step equation skills and I get y equals 4. Now that's really a coordinate point where x is 0 and y is 4. So I can plot that point right there. And I can also put 0 in for y because of my intercept concepts. If I put 0 in here, make that 2 times 0, it's going to make that go away. So if I'm solving for x, I cover the y, opposite way around. I get 4x equals 8, and I get x equals 2. Now that's really a coordinate point, 2, 0, so x is 2. And I found my 2 points, and I can graph. So for me, and take your graph all the way off the lines. Should be all the way off. Stretch that line out nice and long, go all the way off the graph paper on both sides with arrows on both sides. So for standard form, if I'm solving for x, I cover the y. If I'm solving for y, I cover the x. Now it's a lot of information, but this gets tangled up so easily if you keep hearing it over and over again. It does get untangled more and more. Now today's lesson is not a super hard lesson at all. It should go by pretty quickly. It's called graphing from slope intercept form. So slope intercept form, we first of all have to realize that it looks like this. The algebraic form of it looks like this, y equals mx plus b. Now you've seen this many, many, many times when we solve for y. This is like our standard two-step equation form that we have used so many times in previous lessons from last trimester. So it would look something like this, like y equals, let's say, 3x plus 5. Again, our standard two-step equation form that we're very comfortable with, we've used many times. And if we're solving for y, this is the form that we're going to end up getting it into all along. Now we have to keep in mind for this one, when we're talking about graphing from this, is m stands for what? The slope, right? M stands for slope. So all I have to do is look at the coefficient. The coefficient is the slope of the line. So that's pretty easy to do. B, in this case, right here, B stands for the y-intercept. So when I'm working at graphing from slope intercept, the two things that I'm getting are slope and the y-intercept. And if I have the y-intercept and I have a slope, I can graph a line. So in this case, 5 is my y-intercept, so I can plot a point at 5. And my slope, in this case, is 3. So my slope is 3, and my y-intercept is 5. So if my slope is 3, then from this point, I plotted this point right here. If my slope is 3, then that means I'm going to go up 3 over 1, up 3 over 1. And if I get at least 2 points, I can graph those with a straight edge, going all the way off both sides of my graph so that line is nice and long and strong, and I'm going to have a positive slope that's at a pretty steep increase, a pretty steep climb that graph is doing. All right, let's try another one. What if my graph looks like this? Or what if my equation looks like y equals negative 2, whoops, I meant to put an x there, negative 2x minus 4. What is my slope? My slope is negative 2. And what is my y-intercept? My y-intercept is also negative 4. Where is negative 4? So start by plotting the y-intercept. Plot that point right there. And if my slope is negative 2, that's really negative 2 over 1, right? It's really that fraction negative 2 over 1. So it means I'm going to go down 2 over 1, down 2 over 1. I get my points, and I can graph them going all the way off the graph on both sides. There I have a steep negative incline going from there. Right, there are a couple things. That's the straightforward, simple, easy ones to do. A couple of other little tweaks to kind of look at to get familiar with it. What if I'm handed something like this? 2y equals 4x minus 8. What if I'm handed something that looks like that? Is that in our standard form like we usually like? It's not. So what do we need to do? We need to solve for y, right? We have to isolate the variable by using inverse operations. What's keeping the y from being by itself? It's multiplied by 2. So the inverse operation is to divide by 2. So I will divide by 2. I get y equals remember that we will rewrite this as two fractions. So we get 4x divided by 2 minus 8 over 2. That's going to end up giving us y equals 2x minus 4 when we simplify it. This now is in slope-intercept form, and if it's in slope-intercept form, I can graph it. My y-intercept is negative 4. Plot that point. My slope is positive 2. So from here, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So for these, I need to remember that I need it in slope-intercept form. I need it in that y equals and then everything else on the other side, having a coefficient, the variable x, and a constant on the other side. All right, last three things to take a look at. And of course, I won't go through it right now because that's a separate lesson. Just a reminder, if I had something like 4x minus 2y equals 10, I still would need to solve for y. Would it be helpful to quickly review that? Solve for y? Great, I'll do it really quickly here. There are other videos and lessons in the past that we've done on solving for y. So if solving for y is something you're struggling with still, make sure you reach out and ask for help on that. So just a quick review for now, just kind of dust the cobwebs off of that. If I'm solving for y, what's keeping it from being isolated is it's multiplied by negative 2 and it has a 4x added to it. So we have two pieces we have to get rid of it. So first we're going to move the constant, which in this case is negative 4x. Subtract minus 4x from both sides. We get negative 2y equals. We do not combine these. We leave them chunky and clunky. We leave them separate. We leave it as negative 4x plus 10. From there, we'll divide by negative 2 from both sides, and y equals. We are going to rewrite this as two fractions. And then we're going to get negative 4x over negative 2. Don't skip this step until you get really, really good at these. So when you simplify that, we will get y equals 2x minus 5. And there's our slope-intercept form. From that, we can graph. The y-intercept will be negative 5, and the slope will be 2. All right, quick review of that. Again, if you're not good at solving for y, you're going to need to be good at solving for y, so make sure you ask for help with that. Let's see, what if I have something like this? Y equals 2/3 x plus 4. What if there's a fraction in there? This is going to be your favorite fractions to have of the whole year. These fractions are super simple to do. There's my y-intercept. My y-intercept is 4. So I'll plot that point at 4. And my slope is the coefficient. My slope is 2/3. So what do? From the y-intercept, I'm going to go positive 2. So I'm going to go up 2. And then my run's going to be 3. Remember, always do your vertical change first. So if this is a positive 2, you're going up 2. If it's a negative 2, you're going down 2. But you're always going to run to the right. You're always going up and to the right or down and to the right. Always, always for these. So here I'm going to go up 2. So I'm going to go up 2, and then I'm going to go over 3. Up 2 and over 3. Up 2. Actually, don't draw the point, so just I want to put the dot right there. So you wouldn't actually draw these little lines right here. You just would count them. So up 2 over 3, up 2 over 3. So you're going to make those dots, and when you connect them going all the way off the graph, you have your graph right there. So that is y equals 2/3 x plus 4. Right? And the last ones, a couple exceptions. What if I get y equals 4/5 x? What if I get 4/5 x? What is the constant? What is the y-intercept? Remember, there's an invisible plus 0 right there. So our y-intercept is the point of origin. It's dab smack in the center of the graph. And if our slope is 4/5, we're going to go up 4 and then over 5. We're going to go up 4 and over 5. So that fraction tells us up 4 over 5, but it's going to go through the point of origin because there's that invisible plus 0 right there. And the very last one we're going to see, sometimes we might see something like x equals 6, and we're asked to graph that. So x equals 6, what is the y-intercept? What is the slope? This one looks a little different, right? So what we're looking for is all of the points in the graph where x is going to equal 6. Well, where does x equal 6? X equals 6 here, that's 0.06. Here's 0.16, 26, 36, 46. Negative 16, negative 26, negative 36. So these are all the points where x equals 6. It is an undefined slope, and it's going to be a vertical line going up and down. So just watch out for those ones where they're just y equals or x equals. And there you go. There you have it. Our lesson on graphing from slope intercept.